Welcome to the Rich Report, a podcast with news and information on the world of big data. Today, my guests are from a company called QuantCell Research. This is a startup, and we have the co-founders of the company, Kris Thorleifsson and Agust Egilsson. Gentlemen, welcome to the show today.
Yeah, thank you very much. Thanks for having us on your show.
Well, it's great to have you guys. You know, I love hearing about startups, especially in the space of big data and HPC. And I brought up your slides. Why don't we go through the overview of your company, and then we'll do a little Q&A after that and a demo. Does that sound good?
That would be great. So thanks again for having us on your podcast. My name is Kris Thorleifsson, as you said, and I'm joined here with Agust Egilsson. We are both the co-founders of QuantCell Research. Let me start with telling you a little more about the QuantCell Big Data Spreadsheet. QuantCell is an end-user programming environment for building analytical models and big data analysis. It is an advanced spreadsheet environment for rapidly building and deploying highly advanced models and applications. Our objective with QuantCell is to enable data scientists and domain experts who are usually not programmers to take advantage of the tools and resources that are available for analytics and big data and are currently only relevant and used by skilled developers. At the same time, our objective is to empower them to undertake more advanced analytical projects, basically allowing them to build complex analysis, models, and applications more efficiently with less reliance on IT teams. And I should also mention here that we recently released the first public beta of QuantCell. It's available for free on our website, QuantCell.com. In August, we released the Windows version, and just last week, we released the version for Mac OS. Now, just a few words about what we consider to be the key benefits of QuantCell. First and foremost, QuantCell shortens the turnaround time for analytical models and applications. This is very important as the demand for rapid prototyping and development of analytical models is growing. This is especially true, though, in financial services, where slower turnaround times may result in lost market opportunities or insufficient response to market threats. There's also a greater need for businesses to take advantage of big data technologies for market insight, to gain competitive advantage, and better analyze and understand the vast amount of data that's being collected. So a software tool such as QuantCell that improves productivity and promotes faster turnaround fulfills an obvious need in the market, we believe. Then there's the cost associated with big data projects. There are two main things that contribute to the high cost of big data analytics. First of all, there's not enough skilled analytical talent and data scientists around who are capable of advanced and big data analytics. For instance, the McKinsey Global Institute has predicted that in the United States alone, there is a shortage, or there will be a shortage of about 140 to 195,000 people with deep analytical skills by 2018, and as well as a shortage of about 1.5 million data-savvy managers and analysts. So we're basically talking here about a gap of 50 to 60% between the supply of analytical talent and the demand that's available. The other constraint is that the big data technologies are relatively complex to implement, require a significant investment in IT, and are therefore usually out of reach for organizations with limited resources. Another big issue we address with QuantCell is that the tools that are available to non-developers are in many ways insufficient and disjoint. They don't support the latest big data frameworks and don't provide an easy path from development to deployment. So empowering analysts and researchers who are not programmers to undertake more advanced analysis is essential. Not only does it help address the talent gap, but it also helps reduce the cost of big data projects. And it also allows more organizations and users to benefit from big data. So who are the users of QuantCell? QuantCell is for organizations and individuals that rely on advanced analysis to gain competitive advantage, solve complex problems, and drive innovation and discovery in business and science. In particular, though, we're talking about users who are domain experts in their fields, data scientists, quant in financial services, analysts, and researchers. These are the ones who best understand the data and what the insight they hope to gain from it. So for the most advanced analysis and big data projects, they are, however, dependent on IT teams. They need the support of developers to build some of the more complex analysis. And the process of taking everything through IT puts tremendous limitations on the analytical projects that the domain experts can and can pursue. Even more so, actually, in organizations with limited resources. So these are the people who benefit the most from QuantCell, enabling domain experts to prototype, build, and deploy their own models and solutions efficiently and with less reliance on IT should result in more productivity and faster turnaround of analytical solutions. Now, another group of people who are users of QuantCell are what we call data savvy managers. These are the people who are typically on the receiving end of the analysis or are the consumers of the models being created. And they're using these models to make business decisions. These users are intimately familiar with and used to working in the Spreadsheet UI, which makes QuantCell an ideal environment for them. And finally, we list here software developers. So while QuantCell is aimed at non-developers, skilled programmers can certainly benefit from QuantCell, especially developers who are tasked with supporting domain experts and are building analytical models for researchers and scientists. But for a Java developer, for instance, QuantCell can be used as just another Java development environment for application development. The advantage of using QuantCell over other IDEs is that it offers dynamic execution, integrated testing and debugging, and removes the need for user interface design. There are 6 fundamental components that come together in QuantCell. First of all, it's an easy-to-use Spreadsheet interface. Secondly, it's an end-user programming environment that delivers code completion and recommendation to support non-developers. There are 3 other key components that we also address, namely easy access to algorithms, data, and compute power. Finally, we also address how solutions and models are moved from the development phase to deployment. These are fundamental components that make QuantCell a highly capable analytics tool for domain experts and data scientists. The QuantCell user interface is a Spreadsheet environment, as I mentioned. There are very valid reasons for our choice of UI. Spreadsheets are, first of all, tremendously popular for building models, especially in finance. The reason being is that they shorten turnaround times, offer dynamic execution, and integrated testing and debugging. We think of the Spreadsheet as the ultimate end-user programming tool and the ideal canvas for mapping logic and creating analysis. Most users are also intimately familiar with the Spreadsheet UI and find it easy to work in. Most Spreadsheets program, however, have very limited capabilities, especially when it comes to working with big data technologies, open source APIs, machine learning algorithms, and many cloud-based resources. With QuantCell, we move the Spreadsheet paradigm forward by addressing these shortcomings. QuantCell takes the Spreadsheet to the next level by bringing the power of major programming languages to the Spreadsheet user, allowing them to benefit from big data technologies and the massive amount of libraries for data analysis and data visualization that are available today. QuantCell also differs from other Spreadsheets in a sense that it benefits from just-in-time compilation and concurrency. It is therefore super fast and capable of taking on very compute-intensive tasks. And furthermore, QuantCell is cloud and HPC ready, which means that it can utilize public and private clouds, Hadoop servers, and HPC grids for compute cycles as required, and can connect to cloud-based data sources and remote databases. Another way that QuantCell differs from other Spreadsheets is that all models created in QuantCell can be deployed independent of the Spreadsheet. And one thing I should also mention, just to be clear, that QuantCell is not meant to be a replacement for Excel. QuantCell is a different product for a different type of work, but with a similar user interface. QuantCell's ultimate objective is to empower the non-developer, and at the center of that is delivering end-user programming capabilities. And we address the challenges of end-user programming from all sides. We lower the barrier for our users to benefit from the analytical resources and tools available in several major programming languages in several ways. We provide features that reduce and sometimes eliminate the need to write code. To support that, we provide features such as formula completion and formula recommendation engines. We also provide an easy and intuitive way for users to find and bring algorithms into the systems from online code bases, ideally with just one click. Same goes for connecting to data sources and databases. QuantCell also aims to simplify how users connect to public and private clouds to access compute cycles, HPC grades, and Hadoop servers. So when code needs to be written, users are only required to write simple code snippets and expressions. These code snippets are more or less the same in most programming languages, and users with background in science and engineering are very familiar with them. Today, QuantCell supports Java code snippets and SQL, and we're planning to add support for R, Scala, and Python in the near future. Last but not least, QuantCell aims to automate deployment of big data solutions into production as much as possible. So, delivering on end-user programming is an ongoing project for us, and we are fully committed to that. It is very critical for our users, and it allows them to focus their efforts on the analysis that they want to perform, instead of sorting out mundane IT tasks, such as how to install this library, how to connect to that data source, how to set up Hadoop, and so on. I've mentioned algorithms a few times. Access to algorithms is a critical part of any analytics platform. QuantCell delivers intuitive, on-demand access to thousands of libraries and tools and big data frameworks from online repositories and code bases. We're literally talking about a terabyte of various algorithms here. In fact, any Java API can be initiated inside the spreadsheet today and become sort of like the formula library in the spreadsheet, if you will. And it is immediately available to the user. There is an explosive growth in open source and publicly available Java libraries for analytics and data visualization in various domains that we are seeing today, and all of these work with QuantCell today. We are not only just talking about the big data frameworks and technologies such as Apache Hadoop, Pig, and Hive, but also commercial distributions of Hadoop frameworks such as the Cloudera CTH distribution. We're also talking about the Open Gamma platform for financial and risk analysis. This also includes Vega for machine learning, BioJava for life sciences, the Chemistry Development Kit, the Apache Commons Math Library, Amazon Web Services API, Bloomberg's Open Market Data API, and many, many more. These libraries are developed and maintained by thriving communities of contributors and supported by various institutions and corporations around the world. And QuantCell users certainly benefit from the tremendous value of this code base. Until now, most of this code has only been relevant to programmers, skilled developers. But what we are doing with QuantCell is that we are opening the doors for the spreadsheet user to benefit from this resource as well. As for commercial and proprietary libraries, and libraries that may have been developed in-house, users can easily use them as well inside QuantCell. QuantCell also simplifies access to data. It is capable of analyzing very large data sets. Big data is typically too large to move around and should reside centrally anyhow. So using a live connection to the data source is ideal and is the approach that we take with QuantCell. QuantCell connects to most data sources, both public data providers and in-house databases, using JDBC or SQL or NoSQL, and can also connect to Hadoop nodes and create real-time queries. Through a partnership with Data Market, a data aggregator, We are now delivering one-click access to over 50 data providers with over 100 million time series. Our data browser for data market is a good example of the end-user programming in QuantCell. Users can browse the available data in the data market browser, and with one click generate an expression in the spreadsheet cell that creates a connection to that data source. And adding intuitive access to more data sources, similar to data market, is something that we're going to be focusing on going forward. Providing QuantCell users with the easy access to compute cycles is another area we focus on a lot. QuantCell runs locally on the user's computer. This is important in order to deliver rich visualization of data and also for computational tasks that are less intensive. For models that require more computational power, not to mention big data projects, QuantCell can utilize public and private clouds as needed. These include Hadoop servers, Amazon Web Services, and various private clouds. Any compute cloud or HPC grid providing a Java API can be configured to work with QuantCell and can serve as the computational engine behind the spreadsheet. QuantCell models derive their performance from the underlying system, whether it be the local JVM, Hadoop servers, databases, or a compute cloud. When running locally, the models benefit enormously from the just-in-time compilation available on the Java platform, garbage collection, concurrency, and other JVM optimization methods. Deployment is another big thing we address, as I mentioned before. Deployment is ingrained into QuantCell's DNA. Moving from building models to deploying them into production is a critical part of the process and is often an afterthought. QuantCell aims to facilitate and automate the path from model development to deployment as much as possible. And we already provide deployment paths into the most commonly used big data environments. Deployment is somewhat complicated and specific to each environment, and we will continue to build this out in the future. This is a very big and important focus area for us and incredibly valuable to our users, and a major part of reducing the time from prototyping to model development to deployment. Another important thing to point out is that models that are created in this QuantCell spreadsheet are independent of the QuantCell environment, and they can be deployed as a standalone solutions. This is very different from other spreadsheet applications in which the models are bound to the spreadsheet for execution. So, Rich, we've shown you a few slides and giving you a kind of the short summary of what QuantCell is working on. And maybe we can, if you have any questions, or maybe we can jump on and have a look at a demo.
Yeah. Oh, before we do that, Kris, I did. I am curious about the genesis of this. Did you guys see a gap in the marketplace or frustration of users, or where did it start?
Well, it actually started with Agust, who is my co-founder. He's the creator of the QuantCell environment, and he used to be a math professor at Berkeley, and also used to work in financial services. So he conceived this idea of basically making real programming languages available inside the spreadsheet environment, and he worked out the prototype that he used himself in both in academia and also in banking when he was working there. And when we came together, working together on QuantCell, we floated the idea with a number of potential users, and we got very good reception from users or potential users that this is exactly what, especially in financial services, this is exactly what people would be interested in using. Do you have anything to add to that, Agust?
No, that's good.
Rich?
Oh, great. And as Kris, as far as the workflow of this goes, you mentioned this is not a replacement for Excel spreadsheets, but how would a user prototype something in Excel and move to this, or what do you foresee there?
Agust, do you want to discuss that?
Sure. So what happens is you just build your application in QuantCell and you deploy it directly against the production system you have running in your company. So you wouldn't have to use Excel at all. it feels like a normal spreadsheet. You can use more complicated things and build more powerful models. But once you're done, you just deploy it directly into your production environment, either as Java code or as sort of a specialized code based on the target environment. So the workflow is just QuantCell to production.
To add to that, QuantCell is not a replacement for Excel. It's more like a replacement for the processes and the workflow that's currently being used. It's a replacement for products such as MATLAB, SPSS, SAS. It's a replacement for the process of when you're a scientist or an analyst and you need something done. Today, you go to the IT department and you start a project, and you get some developers to build your custom solution. So that's what QuantCell is replacing.
And Kris, is there an open source component to this as well?
The open source, QuantCell itself is not open source, but the open source component is actually the terabyte of algorithms that are distributed with the system. As I mentioned, there's a tremendous growth in open source libraries in the Java space, for instance, in all sectors. We're not talking about big data, but we're talking about biotech, machine learning, and financial services, so on. And we actually provide intuitive access to most of these projects and APIs that are being developed and make them available inside QuantCell.
Yeah.
It's just one or two clicks.
And, I'm glad you mentioned biotech, because I know a lot of the scientists there who are not big data experts, they use Excel a lot. Is there a way to move that data over from their existing spreadsheets?
Yeah, so absolutely. But you can just save your. Well, it depends on what exactly kind of data we're talking about. But normally you just save your data as a comma separated file, and then you can open it up as a table in QuantCell.
Sure.
So that's one way. The other way is, well, if you're connecting to databases or something like that, you can connect to the same databases from QuantCell, of course.
Okay. Well, why don't we set up a demo here and let's take a look.
So we just released QuantCell in early August, and this is the client. Now, when you start QuantCell, you're going to have basically a web page that sort of allows us to talk to the user, where the user can learn about QuantCell, learn about the company, get support, and so on. But I'm just going to jump into some of those examples we talked about, and I'm actually just going to start with a Hadoop example. So first thing that is interesting is that when you open up QuantCell, it actually connects to the online repositories and gathers all the open source code that's required to run your models. So, for example, in this case, the first thing that happened is that the system actually downloaded about 100 different open source libraries onto my client, which is what is required to run the Hadoop client in the system, or in any system for that matter. Now, so this example is a short example where we are building a mapper and a reducer, and we're submitting the Hadoop task to a Hadoop server, which is on Rackspace, and this addresses, for example, the compute cycles. We can give the user or as much compute power as he or she can afford to pay for. These can be 10,000 machines or whatever the user has access to. Now, creating a mapper is sort of hard in any language. There are some conventions you have to follow, but still, this is how data scientists work when they're working with Hadoop, and we just allow them to work in the same way in our spreadsheet. Now, in this example, we built a mapper and a reducer that actually optimizes that actually locates an optimal position for a particular store based on some data from satellites. And I'm not going to talk too much about this, but the point is, it's easy to use. Hadoop basically becomes like the calculation engine under the spreadsheet in this case. Now, since we're gonna let's look at a second example, unless maybe you have some questions about this one. So here's an example where we are connecting to a database, and this actually talks to how we allow the user to work with more than one language in the system. Now, in the Hadoop example, you just use Java code snippets directly. You can write any expression here that follows the Java syntax. In this other example, you can just use SQL directly in the cells. And we do this in order to address, well, we know sort of what analysts want to do. We know that analysts want to work with SQL. We know that quants want to work with Python, so we allow that. So we support that. Same with R. A lot of people in this field want to work with R, so we allow you to write R expressions directly in the cells. Here is, but in this example, we're actually just using SQL. And what's interesting or what's nice about using SQL here is that you can mix the two languages together. You can use Java along with SQL or R or Python, and also and it's completely transparent to the user. For example, here in this case, you're referencing variables in the cells and from the SQL expressions, and this is sort of a natural way to work with work in the spreadsheet with using many different languages. So the system is polyglot by nature, which is sort of a hot thing today, being able to work with multiple languages in the same system. So it's a spreadsheet. You can use Java code snippets, you can use R, you can use SQL, and you can use Python, and you can do all of this in the same model. Now I want to show you one more example, which is a little bit more basic. It's what's happening here is that we're just accessing a data server with reference data, and what I wanted to show you is how simple that is. For example, if you want to locate any of those 100 million time series that are in there, these online time series, you basically just search using text or point to the data. So here I've located a time series, and in order to import it, I just press import, and it becomes part of my spreadsheet. So this expression was created for me without. I didn't have to write anything. It's just generated automatically, and this is how we try to. This is one of the many ways in which we try to simplify programming for the end user. We call we can call it programming or scripting. But the other ways the other methods we use, besides from providing these results, is we use, of course, auto-completion, and then we use code recommendation, which means that when the user is writing some sort of an expression in a spreadsheet cell, we will actually mine these open source libraries for similar expressions, and will communicate to the user what's the normal way or the best way, or how others have done similar things in the past, and the users can sort of take that into account when they're building their own models. Now, in this example, we're just importing a few time series about the production of some minerals, and we are using an open source library to predict the future production, and at the same time highlighting a few things like visualization and so on.
Yeah, Agust, I'm curious about, as a user comes in here And do they have a way to look at the output with other kinds of tools that are out there?
So because we base our system around being able to import any open source library, then if you have a favorite Java visualization library, which could be, for example, in biotech, you could be using JMOL or something like that, or if you're using charting, you could be using I think it's called JFrame, something like that. If you import those libraries into QuantCell, which is something that's simple to do, you just pick the dependencies here, and then you either someone has included the repository for you, or you have to add it yourself. But in any case, once you've added it, then you can use that in QuantCell directly. So basically, any visualization library is available from QuantCell. We don't provide those; they just come from different systems, open source or proprietary. Now, by default, you would be working with JavaFX, which is a nice system for visualization as well.
Well, great. So, it was interesting, as you went through this demo, I didn't see you typing lots of code, right? And that's what I might expect to hook these things together. Is that the strength of the QuantCell code, do you think?
Right. So I mean, these were, of course, pre-made examples that we just opened up. But in general, when you're working with a functional language and when you're working in a spreadsheet, the code is very compact. And the reason why the code is compact is because there's no user interface design. You're only worried about the logic in your problem, communicating that to the spreadsheet, and that usually can be done in a very compact way. So you reduce code size by a factor of 10 or 100 just by using a functional language like this one. So that's right. I mean, there is, the expressions are short, and there's virtually no overhead in this when it comes to code.
Well, kind of a wrap-up question here, guys. You've got the public beta. Is it just that easy to you can download this and start kicking the tires on it, or what's involved?
Yeah, so just go to our webpage and download the product and start using it. It's QuantCell.com, of course. It's that easy for now, at least. We long term we're building a freemium model for the product, but we assume it'll always be free to use. Up to a certain point, which requires support.
Well, great, guys. I mean, this is very interesting, and really, I want to thank you both for coming on the show today.
All right. Thank you very much.
Yeah, thank you very much, Rich. And thanks for having us on your podcast.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.